Alright, in this video we're going to be going into details about what a function is versus what a relation is and how they're kind of related to one another. And so the stuff in red is something you really have to know because this is it's tricky if you're not careful, but it's something easy if you just take a minute to think about it. So once we go through this is what you should know. You should know that all functions are relations, but not all relations are functions, so it's only a one-way street. Alright, it doesn't work both ways. So all functions are relations, but not all relations are functions. And we're going to see what both of these are in just a minute. So, a relation is a function if for every input there is exactly one output. This is a definition of a function. Alright, so if I want to know if it's a function, I have to have one unique output for every input, meaning one unique y value for every x value. And your hint here is something y'all have heard in middle school, I think, but most of y'all, when I say, is it a function, you scream out, only if the x's don't repeat. And if that's how you want to remember it for now, go for it. But the definition is the one in blue. That's what a function really is. Alright, so there's 4 ways that we're going to represent functions this year: tables, mappings, list of points or ordered pairs, and graphs. So here's your list of ordered pairs, probably the easiest one. These little curly braces, this is just telling you this is a set of points, ordered pairs, whatever you want to call them, and that this is a relation. So a relation, this is your definition for relation. A relation is simply a set of ordered pairs. Pretty simple. All right, any set of points is a relation. Alright, so the set of points above is a relation. That's not too difficult to look. As long as they give you points, you can call them a relation, but we have to determine if they are functions. Alright, so is this a function? Well, one of the ways y'all said that we were going to figure that out was to look at the x values. Well, if you look at the x values here, you've got 1, you've got -2, 3, and you've got 1. Well, there's 2 1s that are x values, and by y'all's way of doing it, the hint that we said, that means that you do not have a function. And think about it this way: we said the definition formally was for every input there is one unique output, and basically that means we can predict what the output would be. Well, if I ask you what the output of 1 is, you're going to have 2 different things to pick from, because the output of 1 here is 2, the output of 1 here is 5, so it's not predictable. If it's not predictable, it's not a function. Alright, so the grown-up version of what a function is doesn't really rely on the fact that x's repeat. That is kind of the crux of it, but we want to say that for every input there's one unique output, which means it's predictable. So this one would be no, it's not a function. Alright, and here's the other 3 ways to do this. So we've talked about a set of ordered pairs, which I've listed up here, just another set of points. And so to make a table, you're just literally going to put your x values on one side, your y values on the other. We've seen this before. We've created points. And again, this one's not a function because we have 2 1s in the x column, which means it's not predictable for us to determine what y value is going to be popping out. Because if I look at the value of 1 for an input, there's 2 and 3 for an output for that number. So the table is just basically taking your points and listing them in xy pairs. And then your mapping, you're going to take your x values and put them in the first bubble, and you're going to take your y values and put them in the second. But notice I have your hint down here. We're not going to repeat values. So even though I have 2 1s, I'm not going to repeat the 1s in the bubble. The repetition is going to come from these arrows right here. I've got 2 arrows coming from the 1. So we're not going to repeat numbers. We're going to just use arrows to show that repetition's happening. Alright, and then from there, you just look at your points or your table. You say 1 is mapped to 2, so we drew an arrow to 2. And then we said 1 was also mapped to 3 because we had a 0.13, so there's your 1, 3, and so on. So you're just drawing arrows from what x value goes to what y value. And then graphing, we're all familiar with graphing points. So here's the 4 points, and you can see that this doesn't pass the vertical line test at x equals 1. If you draw that vertical line, it's going to go through 2 points. Which again, those are the x values that we were saying were not going to work, because over here in green I've circled that they are repeating. So doesn't pass the vertical line test. We have repeated x's. So however you want to look at this, this thing just is not a function. That's the main thing we're looking at. Alright, so for this one, let's see if we can get this one together. So we've got x and y. So our first point's -1, 2. So I'm just going to put the x and the y value beside each other. Then we have 7, 1. 2, 1, 4, 2, and 3, 1. Now for our mapping, we want two bubbles, an input and an output bubble, X and Y. But again, we don't want to repeat. So in the X column, there's nothing repeating, which is your hint about the function. So -1, 7, 2, 4, and 3. So I need all of those. But over here, I have 2, 1, 1, 2, 1. There's only a 1 and a 2. We don't want to put all the 1s and all the 2s. We're going to use arrows to repeat. So -1 maps to 2. So we're going to go -1 to 2. 7 maps to 1. So we're going to go 7 to 1. 2 maps to 1. So we're going to go from 2 to 1. 4 maps to 2. And then 3 also maps to 1. Alright, so some of y'all are looking and saying, oh my gosh, this is not a function because we have so many arrows going here to 1. It doesn't matter how many arrows are going to a number. We want to look over here on this bubble. Is there more than one arrow coming out, which means it's not predictable again. Remember, that means for every input, we can't predict where the arrow's going. There's more than one. So this is a function. We'll go ahead and answer that. Yes, it's a function because if you want to look at the table or the set of ordered pairs, there's no X value repeating. They're all unique, which means we're going to have unique Y values as well. So if you go graph these as points, you have -1, 2. Then you have 7, 1. And 2, 1. 4, 2. And 3, 1. And notice if I run a vertical line through any of these points, it's only going to hit 1 point. We're only going to hit 1 point ever on this graph. So this does pass the vertical line test, so we have a function here. Alright, another one, just to make sure we're on the right track before I give you your practice. We have -2, 0, 3, 1, -2, 2, 3, 1, 0, -2. So hopefully you're seeing there's a few things that are repeating here already. So let's just pause for a moment and talk about function versus non-function based on just the set of ordered pairs we have in the table. We have -2, that's an X value that repeats. So if I ask you what the output of that number is, it's not predictable. It's a 0 or a 2. Now, you have 3's that are repeating as well in your table. You have a 3 here and a 3 here. So some of y'all are going to be like, oh, well, that means it's not a function even more so because it's repeated 3's on top of the repeated -2's. Well, if I asked you what the output of 3 was, is it predictable? And hopefully you're seeing that, yeah, it actually is this time because for each of those 3's, the output is 1. It's the same exact point, 3, 1, 3, 1. Alright, so this is actually a predictable situation. If I ask you what the output of 3 is, it's got to be 1. There's not two options here, even though we've got it listed twice. Alright, so the fact that the -2's repeat, that does make it not a function. So this thing is not a function. Alright, but if those -2's weren't repeating and we had those 3's repeating, this would be a function because it is predictable. 3 goes to 1 both times. Alright, but for these -2's, that's where the issue comes in. So no function this time. So no can't even talk tonight. No repetition going on. So we're going to put -2, 3, and 0. So there's 2 -2's, 2 3's, and a 0. So we're not going to repeat the others. And then on the other side, we got 0, 1, and -2, and +2. So 0, 1, 2, and -2. Don't repeat your 1. And we're just going to draw arrows. -2 goes to 0, 3 goes to 1, -2 goes to 2, 3 goes to 1 again, which we already have the arrow for, so you don't need to draw it again. And then we have 0 going to -2. And again, to see it in the mapping, there's that repetition right there. That means there's not a predictable outcome for that number. We're going to 2 different locations. And we can furthermore see this in the graph. If we go graph it real quick, we've got -2, 0, 3, 1, -2, 2, 3, 1's already on there, and then 0, -2. There's where it fails the vertical line test, and we already said it was going to be at x equals -2. So not a function, and you can see it all across the board here. Alright, so pause the video, see if you can try this on some scratch paper, and when you're ready, unpause the video and keep checking your answers. Alright, here you go, table, mapping, and graph. And we're saying this is not a function, and hopefully you're seeing it's because there is a repeated 4. And if I were to ask you what the outcome of the 4 was, the output, you wouldn't be able to tell me because there's a 2 and a 1 that's possible. And you can see that in the table, you can see it in the mapping, you can see it in the graph and the set of ordered pairs. Alright, so anywhere you want to look, you should be able to tell me if it's a function or not. So this one is not a function. Alright, so until next time, keep practicing.